Let's take a look at two-dimensional shapes, starting with symmetry. Now this is an example of a shape which only has one line of symmetry. The line of symmetry on this arrow is this horizontal line here. If I make a fold on this horizontal line, then this bottom half will sit perfectly on this top half. And that is the only way we can fold this arrow so that one half sits on the other half. If I were to make a fold here, then this rectangular part here will not sit perfectly on this right hand side because we've got these little triangular bits. We've also got a pointy front, so that this part on the left hand side does not match the part on the right hand side. The only way we can fold it so that we create two perfect halves is by folding it along this line here, so therefore the arrow has one line of symmetry. Here we've got a square. Now a square has one line of symmetry vertically and horizontally, and it also has a diagonal line of symmetry and a second diagonal line of symmetry from the other two corners. So in total a square has 4 lines of symmetry. A rectangle has one vertical line of symmetry and a horizontal line of symmetry, but there are no diagonal lines of symmetry. And if you're not sure about that, then get a piece of A4 paper which is rectangular and see if you can fold it corner to corner, and you'll see that that is impossible. With a regular shape, so here we've got a regular pentagon which has got 5 sides, here we've got a regular hexagon which is 6 sides. A regular pentagon has 5 lines of symmetry. A regular hexagon has 6 lines of symmetry on a pentagon. There's 1 line of symmetry there. If you imagine perhaps a slightly straighter line than that, there's a similar line of symmetry going from that corner to the midpoint of this line here, another similar line of symmetry there, and from this corner across here, and from this corner to the other side. And ideally these would all cross through the very center of the pentagon. So as you can see, 5 lines of symmetry. For a hexagon, we can go opposite corner to opposite corner. There's 1 line of symmetry. There's a second line of symmetry. There's the third line of symmetry. And if we go corner to corner, well, that is not the 4th line of symmetry because that is the same line of symmetry that I've drawn in already. Now the other 6 lines of symmetry are from the midpoint of one side to the midpoint of the other. There's our 4th line of symmetry. There's our 5th line of symmetry. And there is our 6th line of symmetry. So if it's a regular shape, the number of sides equals the number of lines of symmetry. With irregular shapes, then there are simply no lines of symmetry at all, or that sometimes there might be 1 line of symmetry, like the arrow, which was the example at the start. But here, it doesn't matter how we fold this thunderbolt, or this arrow, or this looks like an SD card shape, you can't fold it so that one half sits perfectly on the other. So all of these shapes, 0 lines of symmetry. With triangles, so we've got 3 types of triangle here. This one is an equilateral triangle. And an equilateral triangle means all the sides are identical. Now normally in a question they will tell you it's equilateral, or they might mark the sides like so. And these marks mean these sides are equal in length, thus telling us it's an equilateral triangle. An equilateral triangle has obviously 3 sides. All triangles have 3 sides, but an equilateral triangle will have 3 lines of symmetry. Remember, if it's a regular shape, and the definition of a regular shape is a shape where all the sides are the same length, for regular shapes, the number of lines of symmetry is the same as the number of sides. So 3 lines of symmetry for an equilateral triangle. So here we have what I have imagined to be an isosceles triangle, and again they might tell you it's isosceles, or they might do these little dashes here. And in an isosceles triangle, 2 sides are identical, and in an isosceles triangle you only have 1 line of symmetry which goes right down the middle. Left hand side will fold onto the right hand side. This triangle here on the right, this is a right angled triangle. And usually in a question they will either tell you it's a right angle triangle, or they will have this symbol here. This is the symbol for a 90 degree or a right angle. This right angle triangle has 0 lines of symmetry, but sometimes you can have an isosceles right angle triangle where this side length here could be the same as this side length here, in which case it would have 1 line of symmetry through here. But this right angle triangle has 0 lines of symmetry. Now, things you need to know about triangles are, the key thing is 3 sides, 3 angles, and the angles always add up to 180 degrees. In an equilateral triangle, the 3 angles are identical. So if you divide 180 by 3, then each angle is 60 degrees. In an isosceles triangle, these 2 angles at the bottom are the same. So sometimes you get told this angle here. So for example, if you were told that this angle here was 40, you know the angles add up to 180. So these 2 must add up to 180, take away 40. So these 2 would add up to 140. Divide those equally by 2. That would tell us that both of these angles are 70 degrees. The only triangle that hasn't been mentioned is the scalene triangle, and a scalene triangle is a triangle where all 3 sides are different lengths. There are 0 lines of symmetry, but it's the usual triangle properties in terms of the basics: 3 sides and the angles add up to 180 degrees. Quadrilaterals, here we have a square. So as we've discussed before, a square has 1, 2, 3, 4 lines of symmetry. It has 4 angles and it has 4 sides. Now the 4 sides of a square are all identical, they are all the same length, and the angles are all right angles, so each angle is 90 degrees. So therefore the sum of the angles is 360 degrees. Any quadrilateral has angles that add up to 360 degrees, a quadrilateral being a 4-sided shape. Here's a rectangle, that's also a 4-sided shape. So at the angles add up to 360. Again, it's 4 right angles, so each angle is 90 degrees, so 4 90s to 360. You have 2 pairs of sides which have the same length, so these 2 sides are matching in length and these 2 sides are matching in length, and as we discussed previously, there is 1, 2 lines of symmetry. The diagonals don't work. There's only 2 lines of symmetry for a rectangle, whereas there are 4 for a square. Other quadrilaterals that you might see are parallelograms. Again, it's a 4-sided shape, so it's going to add up to 360 degrees. In fact, all of these add up to 360 degrees. We've got a parallelogram here. We've got a rhombus. This is a trapezium. And we have a kite. So a parallelogram has 2 sides that are the same length. So 2 pairs of sides, so these sides are the same length, these sides are the same length. Also, these sides here are parallel, and these sides here are parallel as well. So it has 2 pairs of parallel sides. Angles add up to 360 degrees, and if I call this angle A, then this is going to be angle A as well. Opposite angles are equal, so A and A, these are the same, and these 2 angles B and B are the same. And also angles B and A add up to 180 degrees. A parallelogram does not have any lines of symmetry. A rhombus, so a rhombus is a type of parallelogram. It's a parallelogram where all the sides are the same length, but again there's 2 parallel sides, so these 2 are parallel and these 2 are parallel as well. Angles add up to 360. This angle here is the same as that angle there. So A and A, B and B, these 2 angles are the same, and A and B add up to 180 degrees. So a rhombus is a square that's been slightly squashed, basically, or a parallelogram with equal sides. And again, a rhombus has 0 lines of symmetry. A trapezium has 1 pair of parallel sides. Again, the angles add up to 360 degrees. That's That's all you need to know for a trapezium. There is another way a trapezium can be drawn. One side will always be a slanted side. It doesn't have to be two sides slanted. Sometimes you get a trapezium where you have a right angle here and here. This is also a trapezium, but the key thing is it only has one pair of parallel sides. A kite, the properties of a kite are again 4 sides. The angles add up to 360 degrees. This side here is the same as that side there, and these sides here have the same side length as well. And another property is that this angle here is exactly the same as that angle there, whereas this angle here and this angle here are not the same at all.